Internal gears demand accuracy few machines can deliver, but this one does. The KPS-20 CNC pinion skiving machine handles hardened steel with ease, combining synchronized rotation and precise skiving to craft flawless internal teeth. Unlike conventional shaping, this method boosts speed and finish while reducing wear. Micron-level CNC control keeps everything in check, even for complex gear profiles. It's oddly satisfying to watch each cut land perfectly, as if the machine reads the material. This isn't just metal removal, it's gear making, elevated. Steel profiles are automatically loaded into position as the HEA 400 beam assembly begins. Robotic arms scan and identify each flange and web plate, then position them precisely for tack welding. Once aligned, the system performs full-length welds with consistent penetration and minimal distortion. The welding robot adjusts in real time based on feedback sensors, ensuring joint integrity across the entire beam. Automated clamps hold components steady during the process, eliminating human error. At every stage, precision and repeatability are prioritized. This isn't just automation, it's structural fabrication at scale. Seeing a robot lay down smooth, flawless welds on such massive parts never gets old. The result? High-strength beams ready for pre-engineered buildings, delivered with speed and accuracy that manual processes can't match. Mining ventilation demands serious power, and this machine delivers. Built for a copper mine, each motor drives massive fan blades directly on the shaft, generating 1,700 kilowatts at 6,600 volts. Special bearings manage both axial thrust and vertical load, designed to last 100,000 hours. Despite the strength, the motor stays compact thanks to an IC411 rib-cooled housing. It's incredible how they pack so much torque into such a tight footprint. Pure engineering focus. Heat, force, and precision. It all comes together in the modernization of this SBQ rolling mill. At Steel Dynamics in Pittsburgh, a cutting-edge upgrade enables the production of special bar quality SBQ steel, with diameters ranging from 3/4 to 3.5 inches, while the older line still handles large bars up to 9 inches. Together, they push out 850,000 metric tons annually, with 500,000 tons dedicated to SBQ grades. It's a massive output, but every bar still demands tight process control. The process begins with billets heated to 1,100 degrees Celsius. After descaling, they pass through a compact breakdown mill featuring a 2-high reversing stand. A grip-type tilter rotates the billet between passes, reducing cross-section precisely. Each roll station uses different groove shapes to reach the target geometry. You can almost feel the heat radiating as glowing billets move between each pass. An insulated roller table preserves heat before the bar reaches the next 4 housingless stands in an HV arrangement. The ends are cropped for uniformity, and the rolling continues with tight interval stands to fully utilize thermal energy. A carefully designed 90-degree roller table transfers material to the existing finishing mill without surface damage. Every detail, even in material transfer, is engineered to avoid defects. The core of the upgraded line is the 3-roll precision sizing mill, PSM, delivering round bars at speeds up to 15 meters per second. The rolls are hydraulically adjusted under load and in real time. Calibration is automated, assisted by CCD cameras and real-time position measurement. The roll rings are inserted from below and clamped quickly into the cassette. All settings are fed to the automation system immediately after cassette change, removing human error. It's a remarkable blend of hardware and smart automation, efficiency without compromise. What's especially impressive is the speed. A full cassette change takes less than 5 minutes. During operation, servo valves fine-tune roll positions within milliseconds, achieving tolerances as tight as DIN 1/8H9. A downstream MAHR gauge scans the profile 500 times per second, feeding live data into the control system for dynamic compensation. Few systems can match this level of real-time correction during hot rolling. The dividing shear then cuts each bar to customer length. On the cooling bed, bars are gently cooled before being bundled and prepared for shipment. This line doesn't just roll steel. It delivers consistency, efficiency, and flexibility that meet the highest demands of automotive, aerospace, and energy sectors. Watching it all run so seamlessly feels like watching raw power under perfect control. Aluminum doesn't give in easily, but this saw doesn't ask twice. The KD 350 miter saw, equipped with a 350mm TCT blade, tackles thick profiles with clean, consistent cuts. Automatic clamps hold the material steady, while a mist lubricator minimizes heat and friction. Cutting angles range up to 45 degrees left and right, handling sections as large as 125 by 100 mm at 45 degrees, or 180 by 100 mm at 90 degrees. A 3-horsepower sealed induction motor powers the process, while CNC machined components maintain repeatable accuracy. Mist cooling keeps the blade in top shape, watching it rip through aluminum without hesitation. It's the kind of efficiency that keeps production lines moving without pause. When it comes to large-scale metal bending, few machines match the presence of a 20-meter, 4,000-ton press brake. The steel plate, long, thick, and heavy, is carefully positioned along the bending bed using synchronized supports and guiding rollers. Once aligned, the hydraulic ram descends with immense force. At 4,000 tons, the pressure is enough to bend steel sections several centimeters thick with a single, deliberate motion. The tooling must be flawless and the stroke perfectly timed. Any deviation at this scale could ruin the part or worse. Even the smallest misalignment can multiply across 20 meters, so setup accuracy is everything. Watching the ram approach with that slow, steady confidence feels like witnessing controlled destruction. Throughout the process, CNC controls monitor tonnage distribution and deflection. Precision is non-negotiable when working with such massive components. Watching the beam bow slowly under uniform pressure is oddly gripping. It's like watching gravity itself redefined. The back gauge adjusts automatically to handle repeat bends, while safety systems and foot pedal controls allow the operator to manage each stroke confidently. Despite its size, the machine delivers clean bends along the entire 20-meter length. Few things in metal fabrication match the raw authority of a press brake this size. When that steel finally folds, it's not just shaping material, it's reshaping expectations of what's possible in heavy forming. That moment when motion meets resistance and metal yields without cracking, always satisfying. Raw steel doesn't become a bearing by chance. It's built through discipline. At the Schaeffler manufacturing hubs in India, industrial bearings are built through tightly controlled processes: grinding, honing, and heat treatment, handled by custom German-engineered machines. Each bearing starts with the inner and outer rings carefully machined, followed by automated assembly under strict quality checks. Massive spherical and tapered roller bearings, trusted in rail and heavy industries, are crafted to exacting tolerances. You can feel the focus in every frame. No step is rushed, no surface overlooked. Deep groove ball bearings, essential in high-load environments, are produced with the same attention to detail. It's not just about output. It's about delivering performance that holds up under pressure, day after day, spin after spin. Massive iron ore deposits are mined, then refined into high-quality pellets using 7.5-meter pelletizing discs and double-decker roller screens. Each step pushes production to 3.5 million tons yearly. What an intense scale! Workers tack weld flanges and webs to form HEA 300 beams. The slightest gap could weaken the entire structure, so every fit is double-checked. Submerged arc welding fuses the joints, creating solid 21-meter sections. Step inside the Royal Canadian Mint, one of the world's most advanced facilities, where art, technology, and molten gold come together in an unforgettable spectacle. The journey begins in the engraving department. Once sculpted in wax and plaster, now refined digitally, every coin's design is brought to life with precision and pride. Modern lasers apply frosted finishes in minutes, a process that once took hours. Gold bars, received from customers, are melted and purified to 99.99%, then poured into molds glowing red-hot, a sight that never fails to impress. Continuous casting produces massive coils of gold, each worth millions, which are then rolled down to the exact thickness for coin blanks. But the magic of the plant doesn't stop with gold. Strips of silver or alloy are fed into high-speed blanking presses, where hundreds of flawless coin blanks are punched out every minute. Workers gather the shining blanks into sturdy trays, stacking them neatly for the next phase. Soon, these simple discs will be transformed into official coins or prized collectibles. Every stage, from gold casting to blank preparation, is a blend of tradition and cutting-edge technology. Step onto the factory floor where strength is forged in fire and steel. In this video, we dive into the intense process of manufacturing the giant iron chains built to anchor aircraft carriers, links that must endure the harshest forces at sea. Everything begins with bars of high-grade steel, cut to precise lengths for each massive link. These bars are heated in powerful furnaces, glowing bright orange as they reach extreme temperatures. Inside the furnace, The air crackles with heat as workers monitor the temperature closely, ensuring every bar is ready for shaping. The heat isn't just for show. It's essential for making the steel malleable, allowing the next steps to unfold. A red-hot bar is swiftly transferred to a massive bending machine. Every second counts as a team coordinates to keep the bar at the right temperature during the transfer. Hydraulic arms curve the metal into a perfect U shape, forming what will become the main body of the chain link. Timing is everything. The steel must stay hot to be shaped without cracking. Before the link cools, it's quickly joined to the previous link in the growing chain. Workers skillfully position the open U through the last closed link, creating a continuous chain. The glow of the heated steel reflects on every surface, adding a sense of drama to the scene. Next, the link is placed in a heavy-duty press. Giant jaws clamp down, forcing the open ends together until they meet. This is a moment of pure industrial power. A single movement can shape steel that weighs hundreds of kilograms. The power behind this step is incredible. These presses can deliver hundreds of tons of force, closing even the thickest steel. But mechanical pressure alone isn't enough. While the link remains scorching, a skilled welder steps in. Using electric arc welding, they fuse the seam, ensuring the joint is as strong as the rest of the link. Each weld is checked visually, and sometimes with ultrasonic testing, searching for hidden flaws that could jeopardize safety. Any imperfection could spell disaster at sea, so the standards here are uncompromising. The process is fast but demanding. Precision and experience make all the difference. With the link fully closed and welded, the chain isn't finished yet. It's reheated and then plunged into a quenching bath or controlled cooling chamber. This heat treatment hardens the outer surface while keeping the core tough and resilient, striking a perfect balance between strength and flexibility. Watching these glowing links transform into a finished chain is nothing short of impressive. The next time you see a giant anchor chain disappearing into the sea, remember the fire, force, and human expertise behind each link. Trust built link by link, forged in the heart of industry. Step inside Arsan Dokum's foundry and witness the raw power and precision behind heavy-duty casting. The rhythmic sound of sand being packed into molds echoes throughout the facility, signaling the start of another casting cycle. Every massive iron part begins its journey with the careful preparation of the mold. Workers shape the sand mold by hand and machine, ensuring every detail will be captured. Attention to detail at this stage is absolutely critical. Even a minor mistake can cause an entire batch to fail. Once the mold is formed, it's coated to resist the intense heat of molten metal and closed tightly. Any flaw at this stage could affect the entire casting. Seeing the team work in perfect harmony as they close each mold is genuinely impressive. Meanwhile, in the heart of the factory, iron is heated in powerful furnaces until it becomes a glowing molten liquid. The heat radiating from the furnace is intense, creating an environment where only the most experienced workers feel at home. Technicians carefully monitor temperature and composition, running analyses to guarantee the right chemical balance. Real-time adjustments are sometimes needed, especially when producing parts with strict material requirements. When the iron reaches its target temperature and purity, it's time for the dramatic transition, pouring. The liquid iron is carried to the molds in huge ladles, and the moment the metal flows is nothing short of spectacular. Fiery streams fill every cavity, bringing the part to life. There's a brief pause as everyone watches the molten metal flow, a moment that never loses its thrill. Once poured, the molds are left to cool and harden. Patience is crucial. Rushing this stage can lead to defects. Experienced eyes are always on the lookout for early signs of solidification, making sure nothing is left to chance. When the time is right, workers break open the molds, revealing rough castings. The smell of hot sand and metal fills the air as the castings are freed from their molds. The raw castings undergo rigorous cleaning to remove sand, scale, and any imperfections from the surface. The parts then move to machining, where precision tools cut, drill, and shape the iron into final specifications.